All right. Welcome, everybody. Welcome. Welcome once again to another day, another sleigh. I think that's what the people say nowadays. And yeah, I'm gonna turn on the light because it looks kind of depressing. Yeah, now it looks a little bit more orange, more happy. Yo, I've been trying to fix my hair because it's going crazy since it's growing so much. So that's why you see my hair wet. Hopefully it'll get fixed as the day goes by. Uh, and yeah, it goes crazy. It goes like, it becomes like this. So I need to put water on it sometimes. Um, but yeah, welcome everyone. Welcome. Good morning. Good morning. Good afternoon. Good evening. And good night. Okay. Yeah. Um, oof. So today. First of all, how are you? How are you? Are you feeling okay today? I am feeling okay today. Thank you. But I wonder about you guys. anyways. Um, so yeah, welcome to this Monday stream. Today we're gonna be streaming, we're gonna be taking a look at some things. Um, I think so today we're going to I'm kind of excited. I'm decently excited because yesterday's stream was a little bit of you know, a little bit of a struggle by the end because we had some weird errors, right? Especially related to the red black tree. And so now I think those errors have been fixed because after stream, I dedicated sort of my evening to try and find where the errors were and try to debug them because I recognize it is extremely, like, at least I would be very annoyed and very bored seeing somebody trying to debug some random thing that it's like, you know, like not even the main project. Um, so yeah, that's what we were doing yesterday, and yesterday I managed to fix it. I'm fairly confident we have, like, at least the fuzzer is not throwing more bugs. So the fuzzer is saying everything is great. And that is an excellent thing. That's an excellent indication. Um, yeah. So I've seen some people that have followed after yesterday, which is quite strange. But Kun 1017 Macniliad Centro FTW Feremaniasi Ajagos Guanjibe. Thank you very much for following. And yeah, okay. So today, what are we gonna do today? Well, I'm gonna show you guys the fixes I made, which are very small, but they're very important, right? And after that, we're going to proceed to just run the fuzzer multiple times, make sure that it's working, which I've done already, which is why I mentioned that I have some degree of confidence that everything is fine. Then after that, we're going to go through our to-do list and check the boxes around it. I think one of our main goals is going to be beautify the code. I want to make it a little more beautiful, a little bit more readable, right? M cried. Hello. So yesterday we were debugging and stuff, and I just spent the evening seeing where the errors were because I recognize it's like really annoying to see someone debugging something and getting frustrated. Because yesterday I was really frustrated. Because I was like, man, we've been dealing with errors for like 4 hours. So yeah. So now I'm gonna transition here to the coding scene. Yo, listen to the music. Welcome to another session at the restaurant. This is the reason why we have restaurant music, because today we're going to be cooking like a restaurant. like the greatest restaurant ever. I don't know what to say. You get the point. Anyway, but yeah. All right. Spin the music. All right. So, everybody's waking up. So, as you people arrive, we're going to be taking a look at other things and maybe re-explaining what I've been doing here. But for now, I think we can just let me change these numbers to 100, which is what they were before. Perfect. And I think there's not much problem. So if we look at the log, you'll see the fixes that I made. So I made 3 fixes, right? 3 fixes. Those fixes are as follows. So I'm gonna stash whatever we have right now and check out each of them. So actually no, I think I can just show them in the current code. Yeah. Anyways, so the first one, fix the red black tree. This is one of the most crucial errors we had, and I solved that yesterday evening. I fixed the red black tree to account for the case where the node to delete is not a leaf node. So this is what we detected yesterday was the problem. And so I just coded that up after the stream because, during the stream, I was like very frustrated, kind of annoyed. And the new code is this, right? So one important thing that I think we missed is that when you perform the removal or deletion, Vicente Alencar, welcome, hello. So I'm signing, remember yesterday we were super, or at least I was very frustrated because I was like, the red black tree implementation, it didn't work and the article didn't describe something. So I fixed that in the evening because I understand, like, for you guys and for a stream, it's like kind of annoying, or at least I would be annoyed if the streamer is like trying to debug something that it's like obscure because they cannot explain themselves and like they don't even know where the error is. So I just debugged it on my free time. And the problem was this, right? When we perform removal on a red black tree, we need to first perform the removal in a binary search tree. The article made it seem that the only thing you needed to do was swap the node with its in-order predecessor or successor, and then mark the node that is the successor or predecessor, the thing we call the heir, for deletion. And the answer is no, that's not the case. If the node that you need to swap with has children, then you have to apply a case where you simply drop that node and then connect its children with your parent. So it was like a special case, and it's not a special case, right? It is normal binary search tree deletion, but it wasn't clear that that's what we needed to do from the article we took as reference when we implemented the red black tree. Since again, I didn't know about red black trees. So it's like if the node to delete is not a leaf node, then the only thing you need to do is remove that node and connect its child with the previous parent. And so that's what we're doing, right? Set the color of the child to black and then link the parent with that child. And if it's the right child, then link it with the right child. And that's it. That was all. And then after that, if the node is a leaf node, only then do the double black cases apply, right? So that was the issue with the red black tree. Okay. After fixing the things related to the red black tree, I ran the fuzzer again and found 2 errors that are not really errors, right? Well, maybe this one. This one is kind of an error. And what was happening is if you go here to the implementation here, if we go to realloc, there was a little guy, give me a second, get stash, apply. There you go. There was a little guy here, if I remember correctly, it was in the case where 2 of them merge or something like that. Here. So this conditional, right, it was, the assertion was saying you're trying to access the free bit of a null heap pointer, right? Because the conditional previously was this. So it was assuming that the next block was a thing, when actually you don't really know whether or not there is a next block. And so you need to include this. So this was the second error, the second mistake that I fixed yesterday, and that's exactly what you see in the log, right? Because it's like fixed conditional that did not check whether end block was a non-null heap pointer before accessing its free bit. So that's what that's talking about. And then we have this one where it was basically a false alarm of sorts. It's described here, right? On the merge both with left and right. So if you go to realloc, we have three cases, four special cases, right? When you shrink, but then when you expand, you have three cases. You merge with your right, and that's enough. You merge with your left, and that's enough. And then you merge with both your left and your right. In this situation, we were doing something like this. We were setting the free bit over here. So we would coalesce, right, with both of them, or coalesce with the right and the left. But we wouldn't mark the block as allocated yet. We would leave it free. Then we would partition that block. And when we partition that block, we would say, okay, right, it's valid block, then, set it to be free or whatever. And then reinsert. And then check that whatever you're doing is, leaves the heap in a valid state. That is, every free block is merged with anything it can merge, which is equivalent to saying there is no two free blocks next to each other, because they would have merged by then. And so here we do next block, then we have a leftover block, and then whether or not the block is free, then, right? So we check that the next block isn't free, because this leftover block is going to be a free block. So we check that the next block isn't free, or it just doesn't exist. And we check that the previous block isn't free. The thing is, if you just partitioned, the previous block is the thing you came from. And since we hadn't set the free bit, this assertion started to jump all over the place. It was saying, oh, the previous block is free, so we would have to have merged with it, but you didn't. The reason is because, this is a child of that huge block. It got partitioned, and since we hadn't marked the previous block as allocated, it was still marked as free, then this represented a problem. So what we needed to do was just, mark the block as allocated before performing the partition. And that's all, right? And so that constitutes everything we need to know about it. Hickpon's just use AI. Yeah. I mean, in this case, we want to learn, right? But who knows? Who knows? Maybe AI would have got it really fast. Oh, man. Yeah. So given this situation, right? Yes, of course. Yeah. So in this situation, right, now we're taking a look at our fuzzer. And what ends up going on is this, right? So we simply make the tests random, which would be our fuzzer. So this guy over here, I would say make this guy. And then we're going to run it. And you'll see that at least yesterday I ran it 30 times and nothing happened. It is not a guarantee of success, but it is something. So you see that it succeeded here. Of course, it's like printing all weirdly because we're doing 100 operations, but it's okay. So, every time we do this, a new case comes up. And the way we know it fails is if the message at the end is an assertion. If it is not, it means that it got to complete everything, right? You can also tell by the number of the operation. This is operation number 99, which means that all 99 operations, since we started at operation 0, have been correct. Right? So all 100 operations, none of them has failed, Because remember, since we fail by an assert, that would imply a crash of the program, which means it wouldn't be able to finish execution normally. But here, if I do this, see, there's no assertion failure. The reason why it seems to not refresh from time to time is because the random seed is based on time, or whatever the time function returns. And it seems like it returns by the second. So, results stay the same for 1 second, but then they change the next second because the random seed changes. So, no assertion errors, as you can see. Fuzzer is saying everything is fine. So now what we can also do is increase this 100 to 10,000 operations, right? So I want to do random mallocs and freeze and reallocs, right? If only there was a way to loop this kind of operations or something. All right, buddy. Yeah, like that is why we have perform 10,000 operations. So we just change the number to know, the amount of operations that we want to do. But yeah, because I mean, if I put this in a for loop, it would be the same as like multiplying this number by however much that is. So yeah. So let's run it now with 10,000. I'm not sure if a heap has enough space. It has 1 megabyte. Nah, it has enough. Okay. Oh, shoot. Okay. So there you go. 10,000 operations of 3 mallocs and reallocs. The bottleneck is kind of the printing process, but there are no session errors at all. Everything seems to be completely fine. Yeah, great. Yeah, that's all. So, perfect, right? I think the fuzzer is telling us, yes, this is fine. So, perfect. Notice that, yeah, I mean, let's run it again. The stream is gonna lag since this just consumes, I don't know, a lot, but we'll see each other at the end of the tunnel because we are performing 10,000 operations with the fuzzer to check the correctness, and I think we're completely good. If this fails with an assertion, then we know there's a bug. If not, then it means it's most very likely right. Ooh, pretty good. Okay. Let's make again, and let's reset. Dang. Bro has manga hairline. What do you mean? I had to wet my hair because it goes crazy. So I needed to be wet so that it doesn't become crazy in the day. Do you know about Malloc and C? We know a thing or two. We know a thing or two. Yeah, you a beautiful straight hairline. Oh, thank you. But yeah, so Ayush Sharma, thank you for joining the stream. And yeah, basically that's what we're doing, right? We are creating our own version of Malloc. So straight in got the exact problem we are tackling. So yeah, when we run this, the fuzzer doesn't complain. The blocks are totally fine, it seems. Everybody's happy. Sunshine and rainbows everywhere. See? It's just thousands of operations. And then, hello, Penguin Operator. So I was describing how yesterday evening, after the stream, I was like a little bit frustrated, right? Because we had all these errors and we had the problem with the red black tree. But I solved this, right? I solved the issues after the stream. And now you can take a look at the fact that we are extremely happy because the fuzzer now returns. So we asked the fuzzer to perform 10,000 operations, and notice now that no assertion mistakes, even with 10,000 operations. I know. This is great. Run it again. No assertion mistakes. Let it ride. There you go. No assertion mistakes. Let it ride. Perfect. Yo, I know. I'm so sorry. The lag, it's because like I execute this, and so now the CPU is like pum, and then the stream is also changing all of the lower bits of the screen, and so now it's like, the bitrate goes down. But yeah, yo, let's go. So there you go. Now you guys can see. It seems like we have, I don't want to say a correct memory allocator, but we have a very decent and something we can be confident about allocator. Right? Because it runs 10,000 operations, all of them random, none of them are failing. This is, a little far from proving correctness through some sort of formal verification process, which would be the ultimate, way to test whether or not things are correct. But our handmade tests pass, although those handmade tests are a little, not the best. And the fuzzer completely goes well. You can do 10,000 mallocs quicker than Windows can open up a dialog box. I mean, this is slow, right? Whatever you saw is really slow, mainly because I'm printing the state of the heap at all points in time, which just hurts, the speed at which it happens. But yeah. So guys, I think, and I am happy to say, we have coded a memory allocator from scratch in C. Yo, let's go. Yeah, we've been waiting, what, 3 weeks to say that line? Celebration. Yo, where's the celebration music? There you go. Let's go! Dude, this has been a journey. It's not over though, because we need to do a couple of things. A couple of things. We need to, well, first of all, make the code a little more readable because we inserted all of these assertions, right? And they're making the code a little ugly and like a little bit difficult to read. But, but Um, we definitely have a sort of, you know, so we just need to make the code a little bit more beautiful and like easier to read and easier to understand. And after we need to measure performance. And that's gonna be a little bit, it's gonna be a hit on us. It's gonna be a little come back to reality moment where we snap back because I'm not sure if a memory allocator is very performant. Um, I think it is good. And I think it is performant in the sense that, like, if you were to replace it in a normal program, there would be not much difference. But I mean performant with respect to the, to the standard, right, to the industry standard in a sense, where allocators are extremely fast and extremely memory efficient. And so for that reason, we're gonna, as Funbiek said, Thanos snap back into reality. So we'll see how that goes. But for now, let's just focus on, celebrating the moment, seeing that we have succeeded, fortunately, and that life is beautiful at this point in time. No? A normal program with your malloc would perform better than a mine. Let's go. But yeah, why do we trash so much on Microsoft? It's kind of funny to do, but for Microsoft. But well, I guess nobody can say that. Yeah, never mind. Yeah. Although I don't know, maybe I end up working at Microsoft in the future. Who knows? And then they'll discover these streams, and then they're gonna be like, oh, who do we hire? No, probably say, yeah, guys, I think, I just want to work here because I want to improve the product. I don't know. I've never worked for them. I'd rather be, whoa, oh, that's a little bit of a overstatement. But yeah, interesting. Anyways. So let's take a look at what things we need to do. So I think I can just go back to the 100 many something that we had. Was this it? Okay. I'm just gonna say git add dot git commit minus m. This is like a chore, right? It's like a milestone. Memory allocator works. Fuzzer ran with 10,000 operations multiple times and obtained no assertion fails. Perfect. We pushed that. Guys, amazing. Okay, we're gonna check out a different branch. I feel I want to call this style slash beautify code. I don't know how else to call it. The products ruined my schooling, my CS degree, my personal projects. I wish I Linux maxed 2 years earlier. Yeah, that is true. All right, people. So now you're gonna want to make the code a little better, right? We may want to, purge a couple of things, change some, the way maybe things are laid out. We may want to find a better place or way to perform sort of our assertions, right? Because some of them are very intertwined with the code, right? Prunch or Prun SHH. Thank you for following. And same for Angel Heimdall. Yo. But yeah, so as you can see, perhaps in the Infinite Coded one, yo, hello, welcome. But yeah, as you can see, right, in the say block access, member variables, the asserts are intertwined with the code, but that's completely fine, right? They're like at the start and at the end, so you know that the content of the function is whatever's in between. So these are very fine, right? And actually, they seem quite nice. The problem is when we enter stuff like the actual malloc function or the actual free function, because I'll show you, right? So now look, right? And we have these like red comments of doom, like do not modify this or stuff like this, right? So yeah, it becomes like a little annoying sometimes. If you could have the assertions at the beginning, as in like these are my preconditions, and then after that be able to have, because notice that now the asserts are living like within the code. Right now they're like over here and then they're here, right? They're like everywhere. And so it becomes a little bit of an issue. Or not an issue, right? It just doesn't seem very like it just doesn't look good in my opinion, right? Maybe here I accept it because it's like right about when we're about to return, right? And so now, makes kind of sense. But the problem is, the asserts are like over here and over there, and they're like everywhere, and there's like red comments all over the place. Do not use pref block unless you know what the previous block is free, right? So it is like there are parts of the code that just don't look as good as they should, to put it one way or another. Is I want to change that. I want to change that. I want to make it a little more, you know, a little better, a little more performant. Performance comes after, but at least improve the readability of some parts of the code. So I think things start from print heap, maybe. Well, not really. Okay, so let's read all of these functions and let's see where we can change things. So we have the static variables. This was a to-do, this we don't need anymore. We have the block member variables over here. So these functions are totally fine, right? They're very simple. Their asserts sort of are separated into the preconditions. Oh, sorry. In sort of preconditions and then postconditions, right? And so it's easy to see what is going on. So these guys, I think, they're completely fine, right? We like them, we love them. And it's easy to know what's going on, right? So maybe here, like block set is free, right? We have this debug statement. And then if this is the last block, the ghost node contains its pref free. So now we, assert all of this stuff, which is great. Right? To obtain the next block, you go to that block, you skip the header, you skip the size, and then you see, okay, is this greater, right? And then you obtain the next block. Previous block is free. This little explanation that we have here, I think can be reduced to just 2 lines. Thus, previous block is free. And I also took the freedom to create a little C-line format because yesterday the formatter, the default VS Code formatter, was ruining everything by putting the keys in like different lines, and it looked really bad. Well, I mean, no, it didn't like really bad, right? Because I know it depends, right? Everybody has like their style when it comes to their code. I've seen many C developers write the things this way, with the brackets are in a new line. I wonder what you guys think. What is your coding style, right? Do we have a chat that is a majority new line curly braces approach, or inline curly braces approach? I'd be interested to know. Personally, I am an inline, as you've been seeing throughout the whole series. And so I created this C-length format, which I borrowed from another project I had, and just created this stuff that I, the way I like things to look. Lex X12. Hola. If you're writing languages which don't have default format, if it does, then we don't care. Wait. If you're writing languages which don't have default format, if it does, then we don't care. What do you mean? Because issue with C++ is when it didn't have default formats, so everyone invented their own, and now they compete. Yeah. Yeah. So, but I was just curious, like, do you guys prefer more like this? I am not going to change my style. Like, I am so sorry. Like, if I'm just curious. But if the majority is like new line, I'm going to to say like, no, we're still going to do it in line. I was just curious, like, which one do you guys prefer? Is it this way or this way? Just curious to know what the distribution is. Um, so you're saying, I imagine like things like Golang, right? Like Go. Go does have a default format, so now, right, there is sort of no discussion, which is, I feel, kind of great, right? Because then all of Go's look like every single piece of code in Go looks the same, so it's easy to read. But in C, when I see the brackets, these curly braces in a new line, I like immediately panic. But yeah, in general, it doesn't really matter. Yeah, completely agree. Completely agree. Right, formatting, as long as the code is readable. I was just curious, right? In general, Dana, Meliodeb, welcome. What theme is that? Do you mean like the theme looks really bad or the theme looks really good? I hope it's the latter. If so, it is a theme in VS Code. You go to extensions, and I think it's the Atom One Dark Pro. Yes, it's this guy, One Dark Pro. Atom's iconic One Dark theme for Visual Studio Code, and I choose, or the one I like is the. I'll show you. Wait, where is it? Theme. Where do I select my theme? Color theme? Yeah, I like the One Dark Pro darker. So that's the theme. Because there's like Monokai theme, which I don't really like that much. Actually, I haven't explored many. Like, I remember once I was like taking a look at the. Wait. Dude, I'm sorry. Whoa. Okay. There you go. I was taking a look at all of the themes they have, and it just, it didn't really convince me that much. This one's not, a base, not really, right? This one looks a little ugly, like those colors not. And then I saw her. I saw the One Dark Pro darker. Immediately fell in love. But yeah, and there's like a bunch of them, right? There's like the Nike flag. There's red. This is what we should use when we do debugging. Wait, actually we should do this, right? It's like, guys, debugging time has arrived, and it's like, boom. Anyways, Solarized Dark, Tomorrow Night Blue, Dark High Contrast, and Light High Contrast. But I prefer One Dark Pro Darker. So yeah, you could run a poll maybe. Oh, wait. How do I run polls in Twitch? Thank you, Christopher. Is this, it's really good. Oh, thank you. Is there any Polish Nazi from Nazi? What is Nat SSI for us? Nazi? Anyways, Penguin Operator. Oh, you're saying hello? Okay. But C++ doesn't support Polish notation for math. So how would you implement it? He said it's debugging time and then debugged all of it. Yeah. Wait, how do I make a poll? Let me see. Can I? Let me see how I can do that. I imagine maybe it's a command / poll. No. Slash what? / goal / followers off / emote only co-stream end Clear your chat history, remove a timeout or a permanent ban, announce purple, call attention to your message with an orange highlight. What? Damn, I didn't know all of these things existed. Mods, help, caller, unblock, wall, on VIP, user, unique chat. Whoa, I think I need to take a look at this. Does anybody know? Yeah, well, I tried inputting slash poll, but it doesn't let me. Time to look it up. How to create a poll on Twitch. From the dashboard, a new creator dashboard. On your dashboard for your first poll, click the create a new poll button if you have never created a poll before. Ooh, let's see. Twitch.tv. And then I go to the creator dashboard, right? You guys are gonna see the behind the scenes. Oh my god. Okay. Yeah, and so let's see. So from the creator dashboard, it says, first of all, click the create a new poll button. Click the create new poll button, and then, well, where is the button? Stream manager? Is it here? Oh no, because that's where my, right? Oh, streaming tools, probably here. Streaming tools. Crowd control. Streamlabs, no. Oh, these are like third-party applications. Well, no idea how to create a poll. How do I make polls? Oh, you need to be an affiliate or partner to make polls. Oh, well, well, that was the end of it all. Let's go. Yeah. So I can become an affiliate right now. Oh my god, we're streaming 67 hours. Okay. Yeah. 20-year-old man, by the way. Yeah, so the analytics, they tell you I'm more than able to become an affiliate, but I don't want to become an affiliate. Yeah. I think that introduces ads and stuff. Do you guys get ads? You shouldn't be getting ads, right? I hope not, because then it's like really bad, right? Hopefully you guys are not getting ads. Oh, perfect. Okay. That's awesome. So yeah, I guess you can guys just tell me, or I'll download some sort of third-party extension that will allow me to just do polls in the chat. Or maybe I can become an affiliate without having like monetization and stuff. I have no idea. I'll have to look that up. Wait. Actually, let me ask that right now. Can I become a Twitch affiliate without monetization? It's also I cannot monitor. Oh, okay. So becoming an affiliate is an all or nothing package that automatically enables monetization features like subscriptions and bits. Interesting. Can I disable subscriptions and bits? Because it's also the fact that I cannot become a Twitch affiliate. I'm an international student. If I enable affiliate, it will be considered as another source of income, and thus I would get deported. So let's not do that. So my question is, your channel will be monetized. You can request to remove yourself from being an affiliate in the future. Emotes, bits, subs, polls, predictions. See, like, I would love this to be possible in the channel. Yeah, so it seems like I cannot. There is no way to turn it off. The agreement is to essentially cover all legalities and liabilities around both you and Twitch making money off your content. So, no, not really. Oh. That's unfortunate. Yeah, can you be affiliate without monetizing? If you sign up for affiliate, you've accepted the agreement for ads and further monetization. I see. Yeah. So it's gonna be it's a little sad. But anyways, it's the way of the water. No. So to create polls, you need to be a Twitch affiliate. And I'm not a Twitch affiliate. I also cannot become one because if I do, then I get deported, right? Because it's another source of income, and I'm on an F1 visa, which is doesn't allow you to work or have sources of income. Polls feel like a strange thing to lock via. Yeah, to me too, right? They're so basic. They're like a very fundamental feature. So hiding it behind a paywall, it's like, it's not the only way. Yeah, that's what I was thinking, right? We can maybe I can look like at things like Streamlabs and like stuff like that. Maybe they allow me to make polls. I think I'm gonna write it down on my to-do list so that I can have it ready for future streams. Maybe tomorrow's stream. Who knows? So let me write it down. Gonna do here create polls. Create polls and then should what's the name? Let's see. Okay, perfect. Wrote it in the to-do list. Okay. We can use pretty simple solution. Twitch chat is type 1 or 2 in the chat, and your bot collects all the numbers. Yeah, something like that, right? So that's there's many solutions to this. This time, I was just interested on the brackets and just to know, but yeah. So yeah. Anyways. So what we have here, coming back to our allocator, we have. How long is this line? It's 135. Okay, let's not do that. I think that limiting the size of the lines to maybe 100 characters. Well, 120 maybe like a good estimate. I'm not sure which one we should use. Anyways, yay. So this is gonna be a very chill stream because we basically finished the memory allocator. Like, I cannot believe this is happening. And so, this is relaxing because we're just now tweaking the code a little. We're just making like little changes to make it pretty. And so life is sunshine and rainbows. So Andrew, you gave me a link. Let's see. Chat.vote. Oh wait, so do I just let's try this out. Imagine I just give away my entire credential. Don't show this on stream. Oh no. Wait. That was a great warning. Thank you, website. Okay. I decide yes. So let's see. Authorizing will redirect you to this. Make sure you trust. Okay. You can always revoke authorization. Okay, authorize. Oh. Well, a little too late, Andrew. That's okay. So, let's see. Type your question here. So what do we type? Do you prefer inline curly braces, inline or new line curly braces? And then enter poll option. So I imagine inline would be one of them. Ooh, and then new line. What's wrong with Twitch's built-in polling? Oh, that it's locked behind the fact of being an affiliate, and I cannot become an affiliate because it represents a source of income. So I will get deported if I do. So yeah, so we're gonna vote on whether or not, I don't know. We'll try this out as a way to test the polls. Inline, new line. And then what do? Start voting? So do you guys type, I imagine you type 1 or 2, depending on what. Oh, look at this. Wait, that's so cool. What the hell? Oh, wait, that's amazing. Yo, we got 3 votes for the inlines. I assume Mighty Baka. What did you just do? Brother, whoa, why are the new people? Whoa, damn. Ah. Okay, it seems like a fair and square fight between, 5 votes, and I think, wait, can I type 1? Ah, yeah. Insta ban, yeah. You're getting banned, Soul Guardian. And Mighty Backup, slash timeout, yeah. It's interesting to know. No? We only have 8 viewers right now, so it's maybe not as representative as, for the entire channel. Ban has been. It's not as representative of the entire channel. No, we'll do this when we have more people eventually. So, yeah, sorting maxing. Banning everybody. Yeah. I didn't even see the poll, brother, brother or sister or something in between. What do you mean? What do you mean? So what did you just type to? Are you an inline or a new line when it comes to curly braces in C and C++? Which one do you prefer the most? Let us know. I finished the poll because I don't want the new lines to win. Definitely inline. Oh. Well, it seems like Soul Guardian is alone. Let's go. Yo. Alright. Wait, that's interesting. So now we know what to use when we want to vote. That's great. Alright. Alright. Check the wiki article. This style has very specific names. Oh, really? Wait, so is the wiki article... Oh, I remember there was some link. I didn't really see it. Indentation style. Let's take a look at that. Computer programming indentation style is a convention. Yeah, we know. Brace placement to Allman. GNU! Oh my god! What the hell? Oh no! Dude, there's no wonder why Linus said this. Bro, no wonder why Linus said this. Brother. Okay. Brother, what? So I feel the best, the styling guide we could follow would be the Linux kernel styling guide. Although it seems rather arbitrary, I also don't like the fact that it's inline braces for everything except for functions. It's like, oh yeah, everything should do inline. Then it's like, oh, but, functions are special. Why? Right? That this inconsistency is well and consistent, but all right-thinking people know that K and R are right, and K and R are right. Besides, functions are special anyway. You can't nest them in C. So, it's a little... So, no wonder why GNU needs to be banned. Whitesmiths is absolutely diabolical. K&R, absolutely incredible. Radliff? What? I thought, the only reasonable approaches are K&R and Allman. Right? What are we doing? If we're thinking about something other than K&R and Allman. GNU, absolutely diabolical. Whitesmiths, completely brain dead. Radliff, raccoon type of coding. Horstman, what even is this, right? Pico Pico and Lisp are the same. Oh no, Lisp takes it further. Lisp introduces two little guys. Okay, yeah, this is a joke. Oh, what the hell? Bruh, what? APL? What? A mathematical notation for manipulating arrays was developed by Kenneth Everson, starting in Harvard University. Interesting. Okay, so basically nobody uses this. Great. Yeah, this looks great. All right, while da 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 da, except for the function, right? Except for the function. APL is pretty cool. Really allows you to think in a different way. So, you mean like APL as the language? In which case, maybe, because I haven't seen APL, and so I would be definitely willing to accept that. If you're saying that this coding style allows you to think in a different way, it's like, no, no, absolutely insane. I sometimes write we were, brother, what? Brother, no, no, please, no. This one would be a fun one to give to the historians. All of humanity has been wiped, and the only thing that remained was Weewa code. I don't know. Ping an operator, you're saying I use Allman style everywhere. Why did you vote for inline then? You voted for inline. You pressed 1 in the chat, no? Wait, am I hallucinating? No, you wrote 1. You wrote inline. Isn't Allman a new line type of thing? Yeah, Allman is a new line. Brother. Okay. Oh wait, we can take a look at the code that Andrew writes. Let's take a look at how it looks. Do you use Allman or do you use inline? Okay or not? Advent of Code 2023. So Andrew. Damn. Day 1. UA. Oh my god, is this? Oh my god. I thought you were gonna give me C code or something. Like, these... Oh no. Oh no. Bro, what? Like, you know, it's like... Guys, what is this? Come on, tell me. Right? If you were to guess, right? Like, what does this do? All I know is this is the proofs symbol. You know, a theory proofs a given statement in formal logic. And like, but of course it doesn't have that meaning here, I assume. Takes the first element of the array. Oh, of course. Of course, bro. Shut up, Andrew. You have no right to live here. Get out of my church. Yeah. But yeah. Get out of my church, buddy. If you're spreading all that satanic knowledge. But yeah. Anyways. Can I see who voted for what so that I can kill them? Let's see. Well, not kill them. I do not mean it like seriously. I'm joking, guys. I'm joking. Can I not see it? What if I click this? Oh, pick a random option, restart the poll, remove all poll options. I cannot see who voted for what. That should be a feature. Huh. Anyways, wait, this poll thing is pretty interesting. I want to write, so combined, they take the last element, brother. Absolutely insane. Absolutely insane. anyways, we need to focus. Fun time is over. Fun time is over. Now you're going to beautify the code with me, and there is no escape. Anyways, wait, I wish I could have like a key binding that just like makes hell time be like immediate. If I press like super key and then like ached or something like that, and then it like just changes everything to red. It would be so funny. That is actually a good idea. Wait, let me try and see if I can create a command that does that. And we can have it on the stream. Create command for unhappy mode. There you go. I'm putting new stuff on Codebag if you want to follow that. Just put wasn't full game jam game in there. So I want to see. So that was GitHub, and then Codebag. I've never used Codebug before. So how do I... Because I don't have an account, unfortunately, but I think... Do I put wasn't full? And then it will show me whatever's there. Ooh, Steam Train. Is it this one? So everybody, follow Andrew Krajewski. Whoa, this is a mental picture. What is this? Where did you get this from? What even... Oh, is this like soldering something? And then it seems from some... What is this? Anyways, maybe you can explain us. I don't trust Coder. Okay, guys, follow Andrew. I cannot follow because I don't have an account. Oh, damn. Andrew, you're like the Zig Master. What the hell? Oh, wait, do you have it published? Wait, let's play this game for a little. While. Alright, Funtime is back at it again. We are playing Andrew's game right now. So, let's see. I don't trust any sort of alternatives to stable big platforms. Is this picture with a strange filter? Wait, let me see. Let me take a look at the original picture before we play the game. Oh, that's very different from what I thought it was. I thought it was like from the lens of some sort of infrared camera or a heat camera. You know, this is like a little piece of I don't remember. Estaño is the name in Spanish, like the thing you use to solder. And this was the thing that was soldering, and that's why a bunch of heat was coming out. It is very different from that. It's a pretty cool picture though. I feel it's pretty memorable. I also don't know what this is. I think it's like a wind turbine, but like with, you know, Star Wars lightsabers coming out of it. Who knows? Anyways, all right, let's start. Oh, what's going on? Do I need to connect them? What do I need to do? Oh, shoot. Oh, I arrived. Oh, wait, do I need to connect the tracks? Oh. Wait. So now this guy... Whoa, what's going on? Wait. Oh. I died. Okay. Let's understand this game. Okay, what do we have to do? So we have a little car, and we have to get it here. Let's see. Is that the goal? And we cannot crash into buildings. And then it seems like we need to do everything in the same amount of steps. Okay. Then I continue. Then I need to take this car to that same guy, no? Oh, but wait, I already drew a track through there. So if I try to go straight, I'm gonna crash? Oh wait, no, I can do that. Okay, that's great. And so I need to drive it there too? Wait, but I can do that just fine, no? Oh shoot, they're gonna crash! Oh no, oh, I see. Dude, what? Okay. Let's try it one more time. So these two things, what does that mean? Do I have to connect with them? Okay. Okay, I can connect with either of these three, if I understand correctly. So what I'm seeing is, in the future, we will want to reach this guy. So probably we don't do that. Okay. So now we want to reach this thing. So the more reasonable explanation would be to do this, and then... Okay. And now... Ooh, now we're in trouble. Oh no, we're not in trouble. Right? Question mark? Oh, shoot! Oh, that guy stole... Oh, never mind. Oh, unlucky. Okay. Continue. And so now we need to connect with either of those. But the train is gonna come out of this one and then they're gonna crash here. So I have to go here. Okay. Okay. And now I don't think they're gonna crash, are they? Oh my god, I think they're gonna crash. Okay, so I'm gonna be very mindful and I'm going to delay their death. Wait for that train to cross. And now I can go calmly. Yo. Oh shoot. Oh wait, so is it just an infinite game? It just goes on and on and on and on and on. So if I go to this one... Oh shoot. It's 10 points max. Oh, people, we're gonna reach it. We're gonna solve it. Okay. Okay, I think if I go up... Oh shoot, what is that guy doing right next to me? Oh wait, no, I think he's fine. I go here, then I go back. Then I intercept this and enter. Oof. Tough. Oh. Oh, what? What? How am I supposed to solve it now? Wait, no, this is so unfair. Wait, because now no matter what I do, I'm just gonna crash. Right? Yeah, no, I'm doomed. Ah. Yeah, that's a pretty entertaining game. It's built in Zig? Damn. Pretty good, Andrew. This is excellent. So everybody, follow Andrew on Codeberg, and we're also on GitHub too, if I remember correctly. On GitHub, I can follow Andrew. And I can follow you guys. Yo, let's go. I imagine your projects on GitHub are also Zig. Everywhere. Ooh, it's the same picture. Yo, Ziglag. Yeah. Damn. There you go. Advent of Code 23, Screen Door, Chess, all in Zig. We're gonna learn Zig sometime in the future. Let's go. All right, all right. Let's go back here. Okay. Let's try and finish the beautifying of the code today. We don't have to worry about it later. But yeah, that was a fun intermission. Thank you, Andrew, for the game. But yeah, let's see. So we were looking at these functions, and they seem to be completely fine. Right? We didn't really complain about them. Yeah. Well, I'm God. It was understandable without any explanations. Yeah. It was pretty understandable. Like the first three iterations were like very confusing, and then I was like, okay, I get it. So let's see. We have this previous block if 3. So one thing, does C have the inline keyword? How to inline functions in C? I imagine it does. But yeah, okay, it has the inline keyword. What is the use of the inline keyword in C? Well, we know what it's used for. But, so inline functions, non-static inline. Oh, there's a difference. When an inline function is not static, the compiler must assume that there may be calls from other source files. Since a global symbol can be defined only once in any program, the function must not be defined in the other source files. So the calls therein cannot be integrated. Therefore, a non-static inline function is always compiled on its own in the usual fashion. Wait, what does this mean? Inline function is not static, then the compiler must assume that there may be calls from other source files. Since a global symbol can be defined only once in any program, the function must not be defined in the other source files, so the calls therein cannot be integrated. Therefore, a non-static inline function is always compiled on its own in the usual fashion. So is non-static inline just, simply, it just doesn't inline it? I am so sorry, what does this mean, right? Maybe I'm a little dumb today. Let's read. By declaring a function inline, you can direct UCC to make calls to that function. Yeah, you inline the function everywhere. Yes. Less predictable, sure. Non-static inline and static inline. What is non-static inline in C? Is inline without static or extern even useful, ever useful in C? So, of course, I was missing something. The behavior isn't daft. As the name explains, the idea is to put the definition of the function in the header file and only a declaration in the corresponding C file. Only the extern declaration triggers the generation of externally visible binary code. Not in a .c file, it's only useful in the headers. Inline is all about compiler optimizations, yes, that require the definition of a function to be visible at the size of a call. This can only be achieved by putting the definition in the header, and of course the definition in the header must not emit code every time it is seen by the compiler. But since the compiler is not forced to actually inline a function, an external definition must exist somewhere. Interesting. So if we want to inline things, there's any use for inline in a .c file, but in a header file that makes sense. I see. It is highly likely for you to put inline in place where it's not needed. Always check benchmarks to check if it is really making the difference. That is true. That is true. I guess like I just wanted to place inline for the member functions, at least like these guys, right? Because they're definitely, they're called so many times, and they're extremely simple, and they're there just to simplify the code. But yeah, you're right. I guess we'll leave that for the moment we do optimizations. So for now, we're just trying to make the code readable. Block is free. Marking functions as static makes sense. Making it non-static sometimes prevents compiler from inlining them. Yeah, like as we were reading the explanation, it seems like it made some sense, right? Like you need to know what the function is before the compiler is able to even inline it. I'm not completely sure though, but we'll take a look at it maybe later when we actually do the thing. Yeah. So here, we have this. Then prev block is free. This is completely fine. This seems to be normal. Yeah. The assertions. Let's see. Let's see what assertions we have. So we have is a valid block. We have all of this stuff. Perfect. So I think this is valid block is a little obscure, but it's completely fine, right? Like I don't really mind it. I feel like I'm gonna do something like this. And put things here, then put things here, then perfect. Then maybe we can comment on what each of these do. So this one's pretty self-explanatory, so I'm not gonna say anything here. Feel over here I can say something. Last byte of block is within the heap. That's one thing. Then here we have whenever the block is free, footer is present. And then this one is also pretty self-explanatory, so I'm not going to include anything. Function won't be inline if it's in another compilation unit, unless you use link time optimization, and I'm not sure you do. Yeah, I don't. You need to have the FL2 flag it. Yeah. I don't have that flag. I mean, we could include the flag, and then everything would be fine. But yeah. So we'll take a look at it later. I think the print heap function was pretty useful, but we don't really need it anymore. I'm going to keep it here, but I'm going to delete the calls to it later, like across the program. So we have partition block, right? And partition block is a function that we only use here, if I remember correctly. So let me check that that's indeed the case. Partition block. It should be, right? It should be something we only use here. Perfect. So let me actually, I want to delete it from, well, what happened? Okay. I want to delete it from the header file. In fact, it was on the temporary, so. And then I can just mark it as static, right? To make sure that like, oh, this guy is only used here, right? Because static, okay. I feel I get a little confused in these. It's good that, by default, all C files are compiled and optimized independently. LTO makes it so they are optimized together, making inline impossible across compilation unit boundary. Interesting. So what prevents LTO from being the default? Because it seems like it would be the better thing to have, right? Let me look this up to make sure that what I think this thing is doing is the correct thing. Yeah, that is restricted to the file. Okay, so static applies, the static keyword applies as the usual keyword. nothing is changing. I just want to make sure because you never know with C. Okay, we're doing partition block, right? So we're asserting whether or not the block is valid. Yeah, so we have these logs over here. And I'm not sure if I'm a big fan of the logs. One downside is it's slower to compile. Yeah, but like C compiler is allegedly already pretty slow. But it's also really hard to change default settings because you will break a lot of code. I see. I see. Let's see. The size needed is greater or equal to this. And the size needed is going to be aligned to whatever we need. And the total space, the total left space, and the total right space, it's just going to be this much. So something I want to see is we have this assert, right? We want to assert that the total right space is enough to host maybe not this much, but the minimum size of a block. So alloc block header plus the min block size, I think. Minimum block size, yeah. So that's what we want to assert instead. We can only have this assert after we have performed sort of all of the calculations. So this is the sort of thing that bothers me. I feel like I would prefer it if all the asserts were at the beginning so that we know, oh, these are the preconditions. But we need to perform all these calculations before the function even starts. And so I'm not sure how to, right? Because I want to communicate what the main part of the function is rather than, anyways, try to store the important state you need in variables because all of the block moving and manipulation changes temporarily metadata. Changes metadata temporarily. So that's better. So this is a good warning to have. Can we maybe reduce it to a single comment? Metadata will be corrupted temporarily. I feel that's a better comment, right? Metadata will be corrupted temporarily, and for that reason, it's better if you just store it in variables. Perfect. Store the important state you need in variables. Metadata will be corrupted temporarily. Perfect. And so now this is the gist of it, right? This is the actual thing. So here we have is free block, right? Then we set the size, we set everything. If it's allocated, we don't want to override the footer. So something that I've been noticing is like, we very often do these sort of calculations where we need to perform a sort of change where we obtain like, you know, a block pointer and then we, you know, offset by however much. So you can see that this pattern of mem heap low and then adding something to it, like if you just look up this with the plus, we'll find like, see 12 occurrences. So like we do this a lot. Like a lot is, you know, a lot. And so I think it would be, do you guys think maybe it would be fair to create some sort of macro that allows us, because we had that before, right? We had a macro that did that was called something like fine. It's like block pointer or something like that, or block to pointer. It was something like this, where you pass in the block and then we just perform the whole calculation that you need to know which memory pointer is the one that this block represents. So something like this. Right. And so now we could replace like every call to be, "Hi, Negvosa. Wait, I haven't seen you in the chat for a while. Good news, Negvosa. We have finished the memory allocator basically. At least we know we have checked correctness and it seems to be correct. We created a fuzzer that does random operations. We did like 10,000 operations of allocs, free reallocs. None of the data got corrupted. Everything's merged together correctly. The heap expanded by what it needed to expand. And we ran that like 15 times, 20 times, and nothing happened. So we have the decent degree of confidence that it is working as intended, which is great. So yeah, good news, good news. So I hope you're happy. So yeah, I should actually. Do you guys? There you go. I actually haven't used my glasses in quite a while. I don't know why. But yeah. All right. So here we have the block member variables, right? Cool. I use an actual fuzzer. Not some sort of memory fuzz or anything like that, no. I call it fuzzer because it's like similar in concept, in the fact that it just does like random stuff to try and find some sort of bug. We don't use a memory fuzz, of course, like we're not trying to do defensive programming of any sort. The thing I'm calling fuzzer is just our guy that does random operations, right? So, do 10,000 operations, and then it picks a random number between 0, 1, and 2. 0 is an alloc, 1 is a free, and 2 is a realloc. And then it just chooses a random block, right? Choose a random block and just perform the operation on that, and then right? Yeah. So can try using AFL++. It makes attempts less randomly. What do you mean makes attempts less randomly? AFL++. Fuzzer AFL. And make fuzzer, more speed and better mutations, more and better da. Here's some information to get sorted. Docs read me. Oh, really? Can observe how your code executes and it allows it to modify its input to reach new branches in the code. Whoa. Get a small valid input file that makes sense to the program. When fuzzing verbose syntax, create a dictionary as described in here. The program reads from stdn, run AFL fuzz. Wait, actually, we should use this in the future. Let me bookmark it. To make a more, an even more robust fuzzing attempt. And then, yeah, for example, if you have check in a code which compares input string with some password string, if you have check in a code which compares input string, it will guess the password. I see. So I assume it just says like, oh, this branch over here, it's expecting this. Let me modify the input to see if I can get there. Interesting. Wait, that's extremely cool. That's pretty cool. How do you even find projects like these? Anyways. But yeah, we should use it. I bookmarked it so that it was there for us to use. Let's take a look here to... Bless you, thank you. sorry. So, I think with the macro we just introduced, we can just call block to pointer and then pass in the block. Right? Block to pointer, pass in the block. And then we skip these many bytes plus the size needed minus the footer size, which I think is still not enough, right? That's annoying. Anyways, so here when we do this, we set the size and then we copy back the footer. I mean, this seems to be a rather, rather simple thing to do. Okay, I don't think we can, make this code for easier or more readable. It's pretty readable. Set the size, set the previous free, set the is free. If it's allocated, we don't want to override the footer. So we copy the information that's in the footer, then we set the size, and then we copy it back. Then we assert that everything is fine. I think it's pretty understandable. Partition if worth it. Let's see. So we assert if the block is valid. We calculate the block space. We calculate the size needed. And then we, I think this type of operation where we do align by the size of, it's also kind of common. Well, not that common, but it's like the operation is intended so that the size aligns with the alignment. Like, let's see. Bless you. I found it from Christoph IT. Oh, Christoph. He's like he's very heavy on Zig. I guess it would explain why. Interesting. I've only seen like one of his streams that I got to catch him when he went live, so yeah. Currently we have yeah. I remember seeing that. It works for the Zig Software Foundation. He's one of the contributors. Which is pretty cool. You've made it when that happens. But yeah. So over here, right, we sort of could we introduce some sort of macro that is called something like align with header, right? Because okay, we perform across the program. We do things like these. I'll show you this expression where we align the size of the I don't know why this panel is open. When we align the size of the block with the header, we align like that entire block, and whatever's left, we give to the user. And so this is like extremely common. And I'm not sure how we could call this because I'm really bad at naming. So it's like, yeah, let's call it that, right? So it's like align either with header or for header. So what is that thing for? That thing is for this. Previously, our header was only 4 bytes long, right? And so it was something like this, 4, right? 4 bytes for the header, and then the remaining bytes for us, right? Which I'll put as a parentheses, right? And then, size, right? They didn't call it first hard problem in programming for nothing. Yeah. So what does that function do, right? Suppose previously we had a header of size 4, and that's where everything, sort of was born. When we perform alignment, right, we want the block to be, the entire block to be aligned to say 8 bytes. And so the thing is, 4 bytes plus whatever size is only 8 byte aligned if this is 4 modulo 8, right? So if they pass me a size that, let's say, is like 13, right? Aligning it, maybe if I call alignment on this, then I would get that 13, closest power of 8, that's 16. So I get 16 here. Well, that's a problem because the entire block is not 8 byte aligned, right? So we don't want to call align on size. We want to call something else. We want to call something like take into account the size of the header so that the entire block is aligned. So what we do is we align the entire block, including the size. So in this case, that would be 17. Then we near 17 to the closest multiple of 8, which in this case would be 24. And then we subtract the header from that. So then align this to be 24. Then subtract the header, so -4. And thus, this section is going to be of size 20. And that makes the entire block 8-byte aligned. So that's that aligned with header. The thing is, I don't think we're going to need something like this because we also want, alignment corresponds to the pointer that we provide to the user too. And so either way, this header of 4 bytes would not be a thing. I think it was just an error on our mental model before. Ideally, we want this header to be a multiple of the alignment so that the pointer that we provide to the user is also a multiple of the alignment. And so I think if we just do alignment on both sides, so instead of using this, let me delete this line. Instead of using this unholy expression, right, this thing, which does what I mentioned, I think we generally can just call align on the size needed because now our program has changed. It behaves a little different from before. We have, our goals and things really clear. So I think this definitely aligns with what we want to do. No, not pun intended. So yeah, I think we can use align. When we do the total left space, we can just, do something like this. And I actually think, we can calculate size needed before anything happens. And then, yeah. So if the block space minus the total left space is greater or equal to the partition threshold, which we define in some sort of macro, then we say, okay, partition the block and then return. So this seems like a very understandable function. It does what it needs to do. And yeah, it's also static because it's only used here. So let's make that clear. And let's add some little document to make sure that we communicate the purpose of it. So I think it does exactly the same way as partition block. I guess I'll only include like a brief, right, that says partitions block only if the partition condition, leftover is at least partition threshold. That's long. So I guess yeah, partitions block only if, and then that returns the leftover block. No heap pointer if none. Perfect. Okay. So that's it. We partition here, and everything is great. It's sunshine and rainbows. Yeah, I think this is good. Okay, let's see what happens here. So call us. Parts of the program depend on this thing overwriting only the header and footer of both logs. Free condition, and then maybe we can include a post condition. Post. I imagine post this with post condition. Okay. Only the header of block 1 and the footer of block 2 will be modified. Perfect, so that's a good post condition to have. Header, I guess, and footer of both, of block 2 and block 1. will be modified. So we're not going to modify any sort of user data or anything similar. So you don't have to fear about this, I guess. Well, yeah, it's just nice to have that comment there. Let's see. So what are we doing here? See, this is what I want the functions to look like, right? All of the assets at the beginning, and these separation lines can show you like, oh, this is the nitty-gritty of the code. This seems to look very readable, right? Because then I just say like, oh yeah, these are preconditions, these are postconditions, and this is like the actual thing I'm doing. It looks very nice. Whereas if I go to here, it's like, it doesn't seem as clear. What are the postconditions? What are the things that I'm asserting? Am I asserting this? Am I asserting this? Like, where does it start? Right? So we'd want like the functions to look something like that. Which I guess we could do, because, I mean, these here are just calculations that you need to perform before you even touch anything, just to know where the blocks are. For that reason, I think we can include a separator here, right? It's like, oh, this is like you preparing for the function, right? Then over here is the nitty-gritty where you do the whole merging and stuff. And then by the end of it, you just do all of the asserts and all the stuff that you need to do. So including these separators, at least to me, makes it more visually appealing. Because now, if I want to know what this function does, actually just look at this. Then I'm like, oh wait, it's pretty clear, right? Before it looked pretty menacing, but now it's like, oh, right? The actual function code is just this. I'm not sure if you guys agree. Let me know if you think there is a better approach. Everything, of course, depends on styling, opinion. So this is extremely subjective. But maybe there's something better than these separators that allow us to convey in a better way the meaning of things and what the function does. I think they're fine for now. If you want to make it even more appealing, you can put it in extra keys. So what do you mean? You mean something like this, sort of like creating its own little closure thing? But then you have a problem. Like this is, scope local variables. So the problem is like, this initial part of the function just makes the calculations that it needs. And then it actually does the code. So we actually need these variables. I'm not sure. I don't think we can use the brackets. But yeah, along the lines of the curly braces, it's like, it's like, oh, this thing should be happening sort of before, then this thing happens after, and then the rest you forget about. So yeah, it also makes scope of local variables to be small. Yeah. So, well, maybe here we cannot do it, but yeah, we can do it somewhere else. So let's see, partition if worth it, right? So partition if worth it, we need to, like, for example, here, right? These are just calculations so that like this block, where is it pointing at? And like, what is the actual block space? What is the total left space? And so on. So that like, you're on your feet. Something similar to how Nalloc needs to know from the pointer you give me. Oh, sorry, free. It's free. Free needs to know from the pointer you give me, like, what is the block we're talking about? Like, yes, this is part of the code, but it's like calculating the stuff that's fundamental for you to even start working. So I feel it's fair to simply include this under a wall of, these guys are just things we need to pre-do. And then the actual nitty-gritty of the function is here, right? And so now I'm able to see, oh, wait, like the actual function is just this. And this is just preparing to execute all of that. Malidev, thank you for following. I remember your chat. Leov1280, thank you for following. And the same for the Makabu. Yo. And so, yeah, I think it's better if we sort of separate things this way. Hello, yo. But yeah, let's see. So when we coalesce blocks, we have something similar, right? Where we say, okay, coalescing. Perfect. Do we need to change anything here? I do not think so. Yeah. I mean, I guess we could replace this branch with like a ternary operator, but I'm not sure if I want to do that. Do 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 da do da da da. Well, I guess, you know, he pointer t block with my prev free so that it's easier to see what we're doing here. So if the next block of block 2 is different from null pointer, then we use that guy. Otherwise, we just use the regular treater block, right? So now this can be simplified to just be set the pref free or whoever is storing my pref free. Feels like a very long name, but you get the point, right? Like, we're using asan after manual validation, right? What do you mean, asan? Whoa, I may have just said a blunder, but I'm sorry, I don't know what asan is. Asan, what is it? See, still like a little bit of address sanitizer. Yes, of course. Yeah, yeah. So I didn't know about the name. Yeah, I think this is better, right? Block with my previous free. Very people don't call it Azan. Yeah. 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 Okay. Perfect. So coalesce blocks seems to be, you know, the right thing. New size goes over there. So this is the only thing we need to do to coalesce 2 blocks. This is a very cheap operation. init, perfect. We lazy initialize nalloc. So time to refactor this code. So I guess we have refactored most of the member variables and stuff. So maybe I can just say git add image m. Of course, as always, style output functions. Okay, I'll be back. Okay, penguin operator. We'll see you around. So here we perform a lazy initialization, right? What we want to do is we want to calculate some padding. We now want to calculate the ghost node size, which rather than this should just be the min block size, right? We just make it as small as we can. And this here just doesn't really need to be that. It just needs to refer to the min block size. Yeah. And so then we set up the ghost node. So the way we set up the ghost node is, okay, let's see what this comment says. It says, other parts of the program, prev block, rely on the ghost node being the first node in terms of heap arrangement. So this is something that we can remove because here we always assert that. We always assert that the block, you know, the red black tree ghost node is equivalent to the padding. Block set left, right? We set the left of this to be a no heap pointer. So left child of ghost node stores the root. Perfect. And then we're going to set the size of this to just be, I think we can simplify this to simply be min block size. Perfect. Now it's way more understandable. Now it's way prettier, which is great, right? Set the pref free of this thing to false, which is also true. Great. So now what we're going to do is we're going to go to assert, right? We assert that everything is in the correct position. And now we enter the nitty-gritty of malloc. So what ends up happening is we align the size, but remember this whole computation we don't really need to do. We simply need to align it. Align the size. Perfect. So now we're going to say, well, allocating these many bytes. This is our sort of debug statement. So I think it should be, sure, it can be here. We try and find a free block. Right, try arbitrary find that. And this is where things start to get crazy because the asserts start to merge with the rest of the code, which I kind of don't like. But it's fine. So we try and find a free block. We assert whether or not the free block is valid. Once we know that it's not a null pointer, we remove it from the red black tree. We set it to free. Okay. Sorry, we set it to be allocated. Then we compute a leftover block and we see if the partition is worth it. If it is, then we simply need to, you know. So this is another pattern that we see very, very often, where we have some sort of leftover block that we, you know, we partition if it's worth it, and then we just let it be. And by that I mean, whoa, wait, there's something weird going on. Was looking at the source. What do you mean when you were looking at the source? You mean like the code in GitHub? Or okay, let us know in the chat. So this pattern repeats itself a lot when we do this, right? Because if you look up leftover block, you'll see all of the occurrences where this happens, where this equals partition if worth it, right? See how many times we did the exact same thing? And it seems like every time it is exactly the same. Set it to be free and insert it in the red black tree. Set it to be free and insert it in the red black tree. Set it to be free. Ooh, this one's a little different. Set it to be free and insert it in the red black tree. Set it to be okay. So they are no. I feel it's fine, and I'll explain why after I read the Macabu's message. Was looking at the source. Would it be useful to add O of 1 small size classes as an alternative of red black trees in front of them? It's something we've been thinking about. We've been creating the allocators to have the red black tree and everything. The answer I would say is yes, right? It would make sense to add like a little list of like small blocks so that we can just go like bam, 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 and get them. But that is something that we will try and do once we do, you know, the improvements to a memory allocator. I want to settle our initial design and our initial everything here, and then focus on the optimizations in a future stream, which is probably going to be tomorrow or the day after tomorrow. But yeah, it's a good idea. So here what we have, right? So we have this weird pattern, right? That so I'll explain why I am a little, you know, a little not too eager about the idea of generalizing this to a function. So despite the fact that we repeat the same operation over and over, there are instances where that operation changes. So namely occurrence number 3, where we do this, and occurrence number 5, right? You may say, well, why should they differ? So What this does is it says, if the block you've given me is too big for the size I need to accommodate, then partition that block and let me know, how much was left. So now I say, if there was something left, then I'm gonna set it to be free and I insert it into my red block tree because it's a free block. Now you may be saying, Sharif, you're not doing it right, because if this is a new free block, then we need to make it merge with its right neighbor and its left neighbor, right? And the answer is yes. The thing is, if we introduce, those would be like branches, something like if the next block is free, etc., 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 which we can actually avoid because at this point in the code, we know for a fact, and that's what the asserts are doing, we know for a fact that the next block is not free and the previous block is not free. So there's no need to even check. The reason for that is because this free block was provided from the red black tree. What that means is this block was free before anything happened, right? And so when we partition it, right, or when we obtain this free block by the rules of our allocator, which is like free blocks always merge with their neighbors, it means that that huge free block, its neighbors are allocated. When we partition it, that fact still remains. Its neighbors are allocated. And so there's no need to check, right? So that's why we have something like this. And that's why there are specific situations where we don't really know that and where we actually do the check. That would be number 3 in shrinking, for example, where we actually don't know if the block to our right is free. So if we are a block that's allocated, right, and then we partition ourselves, we don't know if the block on the right is free or not. And so we actually have to check and coalesce with it and then continue our lives. So it is sort of important, right, that we don't abstract this to a function despite the code being almost the same in most cases, just because it allows us to optimize whenever we actually have some information about, the actual, like, neighboring things, if you will. I don't know. Neighboring conditions, right? And so, yeah. So that's the reason. So I think we can continue. Here we have this, and then this assert. It catches everything. So, yeah. I don't want to print the heap anymore. I feel like this is more than enough. Right? We assert, we return. Great. This sounds fine, I suppose. Despite this not, I'm not a big fan of this, because then it like clutters the function a little bit with the asserts and everything. But I guess it's what we need to do, right? Yeah. So then here what we do is I feel there's actually this common burst here. There is no free block. There is no free block. Right. So one thing we can do is, so no free block. Well, I guess no free block to accommodate this request, right? It's important because there's a difference between there being no free blocks and then there being a bunch of free blocks, but not as big as we need them to be. So then we say, well, is the last block free? So then we got the pref free of the red black tree block. Yeah, I think, yeah, okay. So last block is equal to a null pointer. If the last block is free, then we can actually, I think we can actually simplify this a little, right? Because I Actually, no, we cannot. We cannot. We cannot. Forget about it. Forget about what I say. So instead, what we can do is we say, well, if the last block is free, then we go here and then we say, well, the last block size, right? We grab the memphi. Ooh, brother, what is this magic number? Why do we have a magic number? Oh, this is really bad. This should have been size of block footer. +1. Yeah. Because, I mean, the size of the block footer is like indeed 4, right? So this would be equivalent to this, which is indeed 3, but like, I thought we had gotten rid of all the magic numbers. That's okay. So yeah, then we obtain that footer, then we obtain the size, and then we get the last block, right? When we obtain it, we assert that it's valid, we assert all the things we need, then finally we remove it from the red black tree. But this seems to be correct, right? Yes. So how else can we make this more beautiful? Do you prefer enums or defines for constants? So for constants, I prefer the defines, right? Expansion factor, partition threshold, main block size. Prefer the macros for sure. They're like a little bit more simple, right? So I don't know. Yeah, which one do you prefer? Let's see, is last free, then we arbitrarily removed the expansion size. Enums, because my LSP likes them more. Oh, I see. LSP-based programming. Wait, that's interesting. That's interesting. That's an interesting reason. It's like, oh yeah, the extension, the LSP works better with these, so I just use them then. Interesting. Which I guess makes sense, right? Because like if you just run preprocessor macros, like depends on the constants you're storing. If they become really crazy, I can see why. But yeah, that's interesting. Okay, let's see. So when we perform this expansion size, we do it. Okay, how can we make this more pretty? Sort of more understandable, perhaps. Okay, how do I make? Wait, how do I make CLM formatter respect my new lines? Set column limit to 0 is the most powerful global way to preserve line breaks. When disabled, Planck formula respects almost all of your input line breaking decisions. Ooh, but I want a column limit. So what is it that I'm saying? Like, notice that if I organize this a certain way, because I don't know, I want to make it clear that there's 3 things at play here, right? If I organize it this way, then when I save, the thing just collapses it, right? So I want it to be mindful and respectful of what I'm doing. Just because if you do it this way, it's going to be way clearer, but the formatter just gets rid of it. So I want to somehow, and the problem is I don't want the column limit to be a problem. Do we have, there you go. Somebody's complaining on the Stack Overflow. This person probably did it. Durbeck //n. What do you mean? And by the way, welcome to the chat. Yay. Welcome to the chat. Oh yeah, this person's complaining about the exact same issue. Perfect. Allow short functions on a single line, none will work. solves from a rapid main, but I'm more concerned about the vector initialization in general. Penalty options would help. Example where the above setting doesn't work as expected, the tool no longer shortens for each functions. Okay, so having messed around in the Clang format code, and made some patches, here's my 2 cents. CLang format is based on passing the AST using libclang, which basically eliminates all white space. Oh no. Breaking up the token sequence into unwrapped lines, which are like logical code lines, applying rules, configuration. It's not easy to make it respect the original white space that sort of gets tossed when you first pass the code. You can control where it places line breaks most easily by setting the column limit using the bin pack parameters options. I do not like this. Yeah. Things like this is just going to mangle them, and as far as I know, there's no easy way to make it format them nicely. So you just have to resort either to the lots of trivial comments hack, or use CLang format off when you have something like this. These are just intrinsic limitations of the tool. If you're unhappy ever to have to do things like that, then it's probably not the tool for you. Okay, I mean, I guess we don't have many instances of this, and maybe we can just insert those comments then. I'm sorry, guys. I'm committing crimes against humanity, but it's for a good cause. It's for a good cause. Don't worry. Don't worry. Okay? Don't worry. So we can insert these comments here. That solves the issue, right? In fact, I want to include some comments for each of these. Actually, I think it is, if anything, pretty clear. So I think it's size of allocator plus min block size instead. Yeah, awesome. Hello, extension? Extension, can you react, please? Let's see how much it takes. 1, 2, 3, 4, 5, 6. 6 seconds! That's like absolutely insane. Anyways, expansion size, so we have it like this. I think there was some other thing that I wanted to do this with, and the formatter probably this line over here. So what happens if I save it? Oh no, that's really ugly. Yeah, please don't do this. Please don't do this. How? Wait. Whoa. How to avoid CLang removing new lines in return parentheses. I'm pretty sure somebody has complained about it. Or if anything, now I'm using CLang format off. Okay, yeah, it seems like there is no, you know, there's no, that's unfortunate. It's fine, I guess. Oh, this is a little line break over here. Although I'm not that, you know, not that sad about this one. It's okay. So now let's go back to where we were. And so here we're gonna do, okay, there is no free block to accommodate this request. Oh, there is. There is a way. There is a way. Do you know which one? Info. Oh, you forget it. Wait, is it like, do you not remember or never mind? What do you mean by and forget it? Yeah, it's sad. There's no free block to coordinate this request. So we see the last block free. Previous free, yes, this is correct. We grab the expansion size and we do all of this. Then when we save, oh my god, dude, why? Why are you doing that? Okay, I'm just gonna use select format off. I cannot. This thing is rage baiting me at this point. Yeah, anyways. Why do I not have the trailing spaces? Trailing spaces. Yeah. Why isn't it installed? It should be installed. Okay. Sea-Lang bait. Barrett J Flowers. Hello. But yeah, it's Sea-Lang format is like one of the beautiful tool, yes, but I just cannot. I honestly cannot. It just anyways. Guys, do you know a macro? So we have this max macro, right? But do you know of a way in which we can make the max macro be a little more general, where I can input multiple parameters? Because I don't know much about macros. Differari was doing some crazy stuff with macros. Yes, 2 days ago, he was like, no, actually 3 days ago, he did like function overloading with the macros. But yeah, anyways, so max macro with multiple parameters. Crazy obfuscation with macros. Yeah, it's like I try to remain very sort of away from macros so that this doesn't happen. Because then slowly but surely you're like, oh, we could create a macro for this. Oh, we could create a macro for this. And then it becomes like macro hell. And so now it's like, ooh, right? Like, so max macros. Can we implement a max or mid macro which can take, there you go. Can take variable arguments more than 2 parameters. Yes. Oh, dude, come on. No, this is C++. Oh my god, this guy does not understand it. This guy does not understand it. Ooh, okay, this seems to be a good explanation, although I'm not sure what to... So what is VA-args? What is VA-args? Could just replace the macro with an inline function, variable args. I mean, sure, we could also do that. Yeah, although I don't know how to make like the name is variadic, right? Variadic. Yeah, variadic functions in C. I know in C++, but like in C, I don't know how, because we don't have like a... But it might be the worst thing to ever exist. Let me make it famous. Yeah. That'd be perfect. It seems like a very trivial thing to do. So VA list. Is this a way? Is this a way you do it? VA list, VA start. Huh? In C language, variadic functions are functions that can take a variable number of arguments. This feature is useful when the number of arguments that a function is unknown. It takes one fixed argument. then any number of arguments can be passed. Below is an example demonstrating how to print a variable number of arguments using a variadic function. So we go to the list of arguments. We start with args and then n. And then for each of them, we print %d and then va args, and then args int. So the output is... Oh, but you have to specify the number. That's no fun. Anyways, yeah, this doesn't seem to be what we want. That's totally fine, I mean. Oh, the macabre, thank you. Let's see your gist. Into that. It's a little bit laggy. Sorry about that. My PC is just about to explode. Let me just close some of these tabs because the RAM consumption is crazy. Okay, so you're saying I see static inline static, yes, max n values. Oh, we still need to pass the count. Okay, no, like yes with the values and stuff, but like can we just do it so that it's very simple to do? We just do max and then comma, 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 comma. Because with the inline function, we could do it. Oh wait, never mind. You did do that. Yeah. Sorry about that. Sorry, that you see, that's what happens when you don't read everything. Yeah, the inline function makes the math crazy to write. Yeah, for sure. I think we can definitely use this. Thank you very much. It's a great suggestion. I want to make sure I see how it works. So I'll just do it max, right? Perfect. So it's a max size n, right? And then max is saying constant size t values, and then the count. We do max of value 0, and then for each it values we do max, and then we return max. Okay, yeah, that makes sense. And then I'm interested in the macro itself. So max, it does 3 of them, and it replaces it with max size n, and then a constant size t, then va args. So va args, what does it store? It stores like the amount of like a list of the parameters, so they all have to be the same data type. Oh, Dragon Sahayat, welcome. Does Apple have browser extension like in Windows? Wait, what do you mean? For what specifically? To make it more composable, you can write macro which creates a slice and function would accept a slice. This will work for more than one function. Oh my god. Okay, I feel we're starting to enter macro hell. Is that what it sounds like? Not sure, right? Because then here, let's see, max size n, constant size. So what is va args? What is va args? Is it a sort of internal array that the compiler keeps track of that contains, right? Because what I'm not understanding here is like, here it is being passed as the array, right? Oh wait, no, this is the size of, yeah. So I imagine yes. Nah, this is macro hell. Brother. Please tell me this is something reasonable. Undefined behavior land. Print 1, print 4, get macro. What? This print works in C and does not care about types. Pablo 67. Brother, what is this? Oh my god. Dude, no. Oh no. Yeah, Set jump. No, this is absolutely crazy. Let's not. Only works on macOS because of implicit VA args. Okay, so here when it does the VA args, right? These are available. Wait, when you say it only works on macOS, you mean like this macro will only work on macOS quite literally? Or will it work? Oh, this one's fine. Okay, perfect. Thank you. So I assume it just gives, right, the list of all the parameters. Meant my non-macro. Okay, yeah. I see. Because for your print, you needed like the types to be different, right? So is that the reason? Because I imagine that VARgs has to have all the types the same because of the fact that it's an array of stuff. Maybe. I'm not sure. But perfect. So I think that would be more than wonderful if we get to just do it this way. Because we just grab the expansion size, right? And then we just copy exactly that. Oh shoot. Okay, I think we can just do this, right? Align, and then the max, and then now I can delete this max. And then it just works. Right. Too many arguments in invocation of macro align. Brother, there's only one. What are you talking about? Oh, never mind. You who... Oh, never mind. What? Use of undeclared identifier align. Oh, let's go! Yeah. Okay. I see. Perfect. VA doesn't know about types. It's a macro. Okay, I see. VA is on stack rather than registers on macOS, so you can access it in the way I did. I see. Wait. I think I need to turn on Clank format after this, right? Oh shoot! Wait, what happened? What happened just now? Wait, oh my god. How to stop C-Lang format from getting rid of my new lines? How was it? You use the Clank format no, or like off, but then you have to turn it on again, right? Right, because, yeah, C-Lang format off. So do I just use C-Lang format off with... Because what I'm saying is, like, if I turn it off here, does it only apply to that line, or does it apply to everything after? What? Brother, what? What? Wait, so the comment is not working at all. C-Line format off. I'm turning it off! Bro, what are you doing? What are you saying? I have .C-Line format, right? What's going on? Why is it formatting things that way? So, well, yes, I could try using a different config. What I'm saying is, this should work independent of that, right? But it's currently just not working, which means that the format that it's using is different. Is not, yeah, it's not this. It seems like it's just not reading this. It's without colon. Oh, really? Are you sure? Wait, Control S. Oh, you're right. This guy's just lying. Okay. Anyways. And so I imagine that I have to turn it on back over here. Right. Tuning format on. I see. Okay. Perfect. Yay. So now we continue beautifying the function. So we have a response, we have a memory S break. Then we malloc and we say, okay, the heap expanded by this much. If the last block is free, then we set its size. Otherwise, yeah, okay, no, that makes sense. Otherwise, we need to set its size and set it to be previously free to be false because, right, doesn't exist. Perfect. Perfect. Okay. This seems to be pretty readable, understandable. Block set is free to be this. Then we have a leftover block. So leftover block is a partition of worth it. This is the usual pattern we follow. And yeah, so then we request for this much. Then I don't want to print the heap anymore. And I guess that is the end of malloc, right? It seems like it is. So here by the end, I think we just create a little separator, right? Perfect. It's over here too. Okay, great. I think, is there any way in which we can... The only thing that annoys me are these asserts being inside the code and like everything being mixed in here like a soup. Other than that, I'm fine with how our function is looking like right now. Right. Let's delete this. Left child of the ghost node stores a... Is it you found an issue in the fuzzer? Oh wait, what's going on with the fuzzer? So is this the test random here? Wait, can you tell us what the what is the issue you saw? Because then we can solve it right now. We gotta end the stream in 15 minutes, but yeah, if you can describe it, that'd be great. There isn't a free block to accommodate this request. Perfect. Synonym format off. Synonym format on. Awesome. And then this pattern, I think we can just replace. Is this anywhere else? So I think it's here too, and it's over here, and it's over here, it's over here. Okay, I see. So let me go to wherever malloc was. I think I'm gonna just store this, right? So let's do git dot, and let's comment -m on style malloc. Style malloc. That's fine. And now we can replace all of these calls. So let's look for each call, and this would be more like what we want, where we call instead our macro. Sorry, I just saw a message in chat. Give me a second when I try to do this. A macro for block. Block to pointer, and then the block. Yeah, that's way better. And the same applies here, where we can just do, block to pointer, and the block we're talking about. I think if we do this, it probably fits. Yeah, it fits. Okay. Let me just do that. And then I can just do kind of format of client format on. Let me now read the message. So let's see. When calling realloc, verify the first Whoa, okay, we call him realloc. We call him realloc. When calling nrealloc, verify the first min old size new size bytes before overwriting the return block because the fuzzer currently hides broken realloc copying. Wait. I thought we would try to be careful with it. I see what you're saying. Yeah. We need to include something here. We need to include something in this line. Thank you very much. That's a great observation. Not sure how we missed that. Yeah. We need to compare the memory right after because that is the intention of this realloc block. The intention is for it to be, right, main pointer, then the data that we have. Then it needs to be I guess now we need a macro for min. The minimum between. So we realloc. Well, we don't. Yeah. We need the minimum between bk size, so bk.data size, then the new size. And I should be able to, right, check copy was correct, then sort of, override the data to show that it's a new thing. So yeah, I guess we can just create a min macro. Then I can just zoom in. Sorry, it's not this one, it's this one. Here should be min size n. And then here it would be min of course, and now we need to change all of the values to be smaller than. Great, and then here we do min, and we call min size n. And that's good. Okay, perfect. So now we can try min. Is common.h imported by this? I think so. Yes. Hello? Mr. Macro? Mr. Macro? Hi, Penguin Operator, welcome back. Minimax could be one function to have an argument that determines which it expands. I mean, yeah, it could. I just don't want to focus on them too much. Why is the error persisting? Am I doing something wrong? No, right? This thing imports. I'm gonna make it include column.h either way, although I know that the header file of includes it. Oh, never mind. Well, seems like it didn't. Check that the copy was correct. We check the min between the data size and the size of, that we're shrinking to, or we're expanding to. And yeah, okay, so probably we're gonna get a bunch of mistakes, right? We're gonna get a bunch of errors telling us realloc is not copying the thing it should have. So here I was thinking that thinking that everything was fine, and now we are. Great. Thank you very much for the contribution, the Macabu. That's actually a very, very important thing. Make test random, and then I do /test random. Oh, sorry. /bins. Ooh, assertion failed. Yeah. Let's see what happens. So are we not copying whatever is needed? Assert the memory comparison, then the run byte in the memory pointer gets reallocated somewhere else. And then we assert that the memory comparison between the memory pointer and the data, yes, by the minimum between the two. Yeah. So for these is failing, right? And I don't know why this is printing a -4. Oh wait, it's because we got rid of all the print heaps. I guess like we can just do print heaps whenever we, let me see, return. I'll add a print heap over here every time we return from malloc, and another here. I know I could add it in the fuzzer, but I just want a fast solution for now because we have to go in 5 minutes. So we better do it fast. Let me read the chat for a second. What are you guys saying? Can you try this? Depends on what it is. Let's see. Well, is there a reason why we would need to? I mean, yes, we do have the memory leaks and stuff. I just didn't care about those. Main pointer is new main pointer. Okay, no, so you're doing basically the exact same as that thing. I think I should be more careful with not leaking the memory in the fuzzer. I've honestly been not caring much about it because we just ran it for sake of the test. We're doing the exact same, which is good. Okay. Let me see this. Then let's print the heap to see what is the problem. Ooh. Why is it printing this? It's printing like very anti-leak. Yeah, me too. But since we did it like kind of fast, I think it's a good thing to actually put here in the to-do where we like fix mem leaks in fuzzer. And I mean, right, it's good to start with a nice, thing. We just free, we take data, and then we override it. But of course, like this copy needs to be after, right? After. Check that the copy was correct. Like check data is not lost. Perfect. And then, okay, we reallocate, we check that the realloc worked, and now we just change the data so that, it's evidence of the fact that now we are doing a new step. Great. Okay. Let's reset this. Let's make, and let's run. Oh, shoot. Okay. Oh, seems like we didn't fail on anything. Yay. Okay. So I think like one of my questions would be, why is this printing nonsensical stuff? And by that I mean, you see how it prints like the size of the heap is this much? Did we change something that just made it do this? Because previously it was not printing things this way, right? Something bad is happening. So let me reduce the amount of steps we perform. We perform like 10,000. Let's just change this to 10. Let's reset this. And I have to go soon. Have to go at 10. Okay? Yeah, see? It like prints the weirdest things. This like just straight up doesn't make sense. Like malloc prints the correct thing. Actually no, because the sizes are also wrong. There's something going. Why is it? It all of a sudden just doesn't print the thing that it's supposed to. Did I like mess up when I was doing the modifications and like I changed something that I wasn't supposed to? Let me change. Because I mean, it is correct because the thing is checking that the data is not corrupted and it's still right. But there's something weird with the printing. What is it? And why is it just, thinking that the entire heap looks uniform? What? What? Wait, why did it change? Nothing should have changed. Right? All the changes we made were cosmetic, and we just updated some constants to constants that are equivalent. Right? I think so. Yeah. Like the minimum block size is this minus this, which should be the case, and actually I forgot to put parentheses into this. So what's happening? What's going on? Yeah, this is really strange. I think this is unfortunate, but I think I have to go now. Let me see if we can find it fast. Where is it? Where is the problem? Because previously the heap was printed correctly. It's just printing like values that don't make sense. 20 and 28. Brother, what do you mean 20 and 28? We're printing the heap correctly. Right. Yeah, what happened to it? Okay, let me run the debugger really fast. I gotta go now. But I don't want to leave without checking the correctness because I thought that we had correctness already. And so that would change your plans quite a little. I think we have correctness, right? Like I'm confident that the function does copy the data. But what the macabre suggested, like that little observation that I was actually failing, extremely good. So we malloc, we heap, we everything, end-to-end tests, we seeded, we run, we enter, we initialize. Okay. So let's see what happens, right? We go here to the terminal, to the memory inspector actually. And I want to edit the heap to point to 1, 2, 3, 4, 5, 6, 7, 8, 3, 6, 8, 0, 0, 0, 0. Oh, shoot. Okay. 0x 1, 2, 3, 4, 5, 6, 7, 8, 3, 6, 8, 1, 2, 3, 4, 5. Great. So we do okay. Yeah, there is no memory tab. Like this is just like some extension that we downloaded, the memory view by MCU debug. Because we were struggling, right? There was no way to inspect memory in VS Code, and we were like, ah. But yeah, so we just downloaded this guy. Anyways, the heap looks something like that, and then okay, we see. Pick some random operation. Let's see what operation it picks. It picked operation. Oh, an allocation. That's perfect. Then it goes to the size, and the size it decides on is 252. So now we print here what we want to do. We increase the number of operations. And now let me see what happens when we create that block, right? So we create a block, we create that amount of random bytes, perfect. We nalloc, and let's see what happens in the call to nalloc. So with this, it should lazy initialize because this is the first call to nalloc, so it enters here. It computes the padding, which should be 0 because we're already a by the line or whatever. Let me check. Yeah, the value of padding is 0, right? Yeah. Then we just increase the heap, so now the heap size is 12. 12? It should not be 12. That's a mistake. There you go. It's not only min block size, is size of, because the size does not include the header. Allocated block header. There you go. That's what was messing up everything. Hello? Hello? Set the size to be that, exactly. Yes. It starts here. Okay, so padding plus that. Min block size. We set the previous to be free. Red block tree block. Then we align with the size. One of useful macro tricks is to enable defer. Yeah, this defer I knew of, and I actually proposed it in a previous stream, but general opinion was no, don't use defer because it kind of breaks the flow of the code, which I kind of agree with. So we're not. Well, I was like, oh, let's use defer, but the people said no, so I was like, okay, that's also a very reasonable position. Assert. Okay. Oh, sorry, I don't know why it ended it. I don't agree with that. yeah. I mean, in our case, the variables do change when we return and stuff like that, so we can inspect again later, but for now, I just want to focus on this because I'm already late. But I really want to finish this. Let's see. End-to-end test. Fuck, I missed it. F5. Actually, didn't recompile. Dude, come on, fast. Min block size. Min block size. Then, yes, this is the right thing. Yes, this is the right thing. Yes, this is the right thing. Yes. 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 Okay. Yeah, so we were just using it wrong in that place. So let's just recompile it here. And then go to here. Run the debugger again. I run this. Enter this function, enter here, enter this thing. And then now we open the memory inspector for whatever that value is. So it's 0x 1, 2, 3, 4, 5, 6, 7, 9 EC 8, 1, 2, 3, 4, 5. Oh, fuck. Give me a second. I think I'm. Okay, sorry. Just needed to see if there was something I needed to go to. And then I click OK. Enter and test. Unblocks. Start. Yeah, sure, whatever. Operation. It chose a free, so then it's just going to ignore it. It chooses an alloc. Yeah, perfect. Continue. Then we create the block, and let's see what happens. So enter nalloc right here. Perfect. Lazy initialization. We introduce padding, we shouldn't be introducing any. Then we increase it to accommodate for the ghost node. It's 20, perfect. Yeah. And the response is not known, yeah. Then we say revelatory, the block is equal to padding. We set the left of the revelatory, so we should see the FFFs, yeah. Set the size to be that, so we should see a 10 or something like that. A C being 13. Pref free and color should. Yeah, that's exactly what we need. Then pref free to false. Yeah, okay, perfect. So the min block size, the size of the free block header is 16, plus 4, that's 20. 20 minus 8. 20 minus 8 is 8. So this is a block of size 8. And then 8 plus... Okay, sure. This makes sense. Da, 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 da. 20 minus 8 is 12. And then 12 plus 1 is C. Yeah. And then we assert this. We align the size, so the size should be 192. Then we try and find a free block, which we don't find. Then say this. There is no last block, right? Da, 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 da. The last block is not free because there is none. So then we expand the heap by this much. It says 200. Where the hell is it getting 200? Oh, of course, from the size is really big, so it needs to expand by a lot. Okay, perfect. Then we continue. Ba, 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 ba. And then we set that block to be free. We partition if it's worthy, which it shouldn't. So leftover block is indeed null. Then we continue, and then we return. And when we print the heap, we should see a valid... Oh, assertion failed. Wait, so have we been just having... What? Where were these assertion failures? Assertion failed. Oh, it's because I'm accessing pref block if free of this thing and like it's counting the watch accesses too, which are of course invalid. So I think we can just continue here, right? Okay, I think everything is fine now. Yeah. Okay, so it was just that. I just wrote the wrong thing. So we do this, make test random, and then we execute the bins. Yes, okay, now these are more normal. Perfect. So you have a malloc 63, it allocates a block 64, and it's allocated because it's in parentheses. Reallocate that block number 20 to block number 20. Why is it block 20? Should be block 24. 20 is not 8 byte aligned. Why is it not 8 byte aligned? Which I guess is one of the things that we should be checking here in Nalloc. I'm not sure, we missed it on the asserts. We should always, whenever we return to the user, assert that whatever we're giving back, which is this guy, this thing, is actually 8 byte aligned. So, okay. Let me do this fast. Git log, perfect. Refactor style and nalloc, great, reset. We simply need to fix something in the refactoring, which is the thing at the beginning of nalloc, where when we create the ghost node, the ghost node needs to have a valid size. So it's not here, it's here. So for the ghost node size, just this much, right? It's actually not the min block size, is that thing, but like aligned. So I guess like the minimum block size is this aligned. That should change things, right? Yes. Okay, perfect. So if we run make MM test random, we should see everything is 8-byte aligned as it should. Yeah, so now it starts at 24. And so one of the important things to check when we return from malloc or when we return a pointer to the user is, well, first of all, I guess, you know, get a dot get commit minus m fix both on malloc and fuzzer. Fuzzer. Fix ghost node block to have correct size, and fuzzer to actually check integrity of realloced data. Perfect. So we reset, then we push, and thank you very much to everyone, but especially to the Macabo, because that was a great, you know, git push slash setup string origin style slash beautify code. One thing I do want to take a look at is, wait, did it transfer it? Yes, it did. Okay. Is unit tests, and if I go to main, you check out main. Well, first I would like to log, right? It's fine. Okay, perfect. So what we now can do is change all of these calls to be referring to something else. So let me search for this. Char star name heap low. It's a very common pattern. And we just replace this with the block pointer macro that we created. So bk to pointer of my block. Right. Okay, that's one. The other one is this one. So free block bk to pointer of the free block. Blah blah blah. And then here we have bk to pointer of the last block. And here would be bk to pointer of the block. Perfect. We change this to be bk to pointer of the block and bk to pointer of the block. And then we only have 3 left, more or less the same. bk to pointer of the block. Wait, what is this? Oh, okay, the extension was just low. And then I need to change this to be pblock. bk to pointer of the pblock. And same thing over here. And then Ishwar82, hey, hello, welcome to the chat. And then we block to pointer of the pblock. Yes, block to pointer of the pblock. Expected. Brother, what does this even mean? Oh, okay. Okay, perfect. And now if we go to malloc, we can add asserts for the type of thing that we're looking for. Should be here when we return this. We need to assert that the thing is a byte aligned. So this pointer that we provide to the user, modulo 8 is equal to 0. Well, no, modulo not 8, but alignment is equal to 0. And precedence of operations. There you go. And we copy this to the other places where we expression must have an integral type. It does, no? Oh no, it doesn't. Unit pointer T. Oh my god, invalid what? Invalid operands to binary expression. Oh, okay. Sorry, I gotta go, but I want to finish it. Okay, we return. Return null, sure. Return here. Okay, so this is another assert. Assert that this happens, but instead of free block, it should be last block. Yes, so when we return from free, yeah, that's fine. But then when we return from realloc, that one's also important. So over here, when we return the pointer, we need to check that the pointer is indeed A-byte aligned. If the pointer is indeed aligned, perfect, and then something here. Okay, great. Finally, when we return down here, this thing we need to check, right? Indent, identify free block is undefined. Yeah, that's true. It's block. And then we need to, whenever we return from here, check that it is 8-byte aligned. Yes. Then we do this, but instead of that, we do block u pointer. Finally, oh, for what type of program you're making the memory allocator? Oh, we're just making a general purpose memory allocator. So think malloc, right? Just something that can be used everywhere. We're not targeting a specific one. So we just want, a general memory allocator. It's just that I'm a little in a rush because I have to go, but I want to perform these assertions before leaving. So streams usually in at 10 a.m. and here we are. So it's 10:20 now, which is unfortunate, but yeah. Alpha RMQ, learn my mentor again when in a one-on-one session. Soon, because right now I have to go. I really have to go now because the stream ends at 10 a.m. and as I was saying, like I'm currently in a bit of a hurry since, yeah, I don't know. We need to assert that this thing, this new pointer is 8-byte aligned or whatever something aligned. And that will do it. Okay. Please tell me it works. Element test random bins. Okay, seems like it's kind of working. If I modify this from the 10 that I just did to 10,000, do we see any issues? Let's see. Make test random. Okay, success, success, success. I consider this a success. Um, Great, 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 great. Let me push this. Let me push this fast, 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 fast. Where are we? Where are we? Where are we? Git branch. What branch are we on? Okay. Git add dot. Git comment dash 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 m. And then here it's like a, it's more like a test, right? Test. Here. Add test to verify return pointer is aligned to alignment. Right. Oh shoot! No, I put the wrong thing. Ah. Okay. Comment Hashem. Perfect. And then we push this to the GitHub, and then we're fine. Okay. Perfect. Okay, guys. Oof. That was a rush. I gotta go. I gotta go today. And yeah, I will see you guys tomorrow. I'm sorry it's like so sudden, but as I told you, I have to leave at 10. It's already 10:20 where I am. So yeah. Okay. I'll see you guys tomorrow. Bye bye. Bye bye. And thank you very much to everyone for hanging around. We'll see you tomorrow. And yes, okay, bye bye.